on the test,
June
are we
2016.
gonna have to memorize the?
You have to memorize all. You have to memorize all of them.
I have to memorize all of them.
Yes.
Okay.
Chapter 8.3.
All right. I think it's time to start. All right. Anyway, let's start. So 8.3 is about the equations of lines and linear models. So we have a point and slope form. So basically, this is about the linear equation. And the linear equation, if I summarize this, when you say the linear equation, we usually say that we have two variables, x and y. So typically we have ax plus by is equal to c. And this form is a standard form. And from this, when you want to change the form into dy, so move the, basically solve for y, then move this ax part to the right hand side, then we have a by equals negative ax plus c, then divide by b on both sides, then we have a y equals negative a over bx plus c over b. So this form, like the more general form, we say that y equals mx plus b, which is almost the same as this. So here the m is a negative a over b, and the b is basically the c over b. Let's assume that we have this format. And from this, what I can tell is we can tell the slope of the line equation, or the straight line. The slope is m. And slope tells us the steepness of the line, or the straight line. And then this b is a y-intercept. The y-intercept is when the x value is equal to 0. So when you plug in x is equal to 0, we get a y equals b. So the y-intercept is a 0, and this form is coded as like a slope-intercept form. So we have one form which is standard form, and we have another form which is a slope-intercept form. And then it may be possible that we may have 2 points. So 2 points are given, and we want to find a linear, like the line equation for the 2 points. In that case, we need a slope. We have to define the slope. So for that case, how can you define the slope? So 2 points x1, y1, and x2, y2. So we have a 2 point. Now we are going to find the slope of the linear line, or the line equation, which pass through the 2 given points. The slope m is a y change over x change. So y change is y2 minus y1, x change is x2 minus x1. And that is a slope. Now let's assume that we know the slope, and then we have one point. So one point is given and the slope is given. Then we can find the line equation. So slope is m and a point. One point x1 and y1. When we know this, what can we get is, we get y minus y1 equals m x minus x1. So this is also important format, and this is also important. So this form is a slope and a point. When they are given, we can use this formula to find the line equation. Now when you combine the 3 and the 4, which is when you have a 2 point, and then when you want to find the line equation, then we know the slope, which is given like this, and then since we know the slope, we can plug in m here, the slope m here, then we can get the line equation. So 2 points are given, and x2, y2. When the 2 points are given, we can find the line equation, y minus y1, which is almost the same as that. Now this m, the slope m is now y2 minus y1 over x2 minus x1 times x minus x1. This is like something like the summary of the whole line equation.
Would you say that's 5 different ways to figure out the slope or the steepness? Or
no, the 5 different, well, maybe like the 5 different formula. So maybe your line equation may be given like just first as like the first one, ax plus by is equal to c.
Right.
Just given like that, then you may have to figure out what is the slope or what is the y-intercept. When you have to figure out the y-intercept and the slope, you have to use the second format. You have to convert into the second format. And then that m is a slope and that b is a 0, b is a y-intercept. Or when you have, so we don't know about the first two. So we only have like a 2 point x1, y1 and x2, y2 are given. Now you may have to figure out what is the line equation, or what is the slope, or what is the y-intercept. Then you have to use the slope m is equal to that when you have to figure out the slope, or when you have when you use the 4, which is the slope is given and the point is given, then we can get the line equation over there. When you combine these two, then we can get the line equation when you have a 2 points are given. So depending on the condition, we can get the different format.
Yeah, depending on how you're asked the question, you
yes.
have to use different ways to get to
Yes,
that.
right. Or depending on your given condition, your given information, you may have to choose one of these type and convert it into from one to another, etc. And then, how can you draw the line equation? For example, let's say that we have a y equals mx plus b. Now we're going to draw the graph of this. Well, everything can be converted into that, right? When it's solved for y. So this tells us the y-intercept is 0, b, and we discussed that, the y-intercept. Now to draw the graph of the straight line, if we know the y-intercept and one more point, just one more point, because we only need the 2 points to draw the line, right? The one more point is the x-intercept. The x-intercept is when the y value is equal to 0. That's the x-intercept. So plug in y equals 0 here, for example. Then we have a 0 equals mx plus b, which means mx equals negative b. So x is equal to negative b over m. So anyway, we got some number like the negative b over m. So we have a x-intercept and then y-intercept. When you know the 2 point, let's say the y-intercept is on the positive side and x-intercept is on the negative side, then what happens is just connect these 2 points. And this is like the negative b over m, and this is a b. That is a y-intercept and x-intercept. So when you get the x-intercept and the y-intercept, just connect them and we get the line equation. And this is the easiest way to draw the straight line.
When you use b there, you're just using it as a variable, it's whatever
No,
number.
Number b is a constant. Number m is a constant. The variables are only x and y. They are variable, and other numbers, b, m, they are constant, although we don't know that constant yet.
That's what I mean. So
Yes.
you're using a symbol to represent we don't know the number.
Yes.
Yeah, okay.
All right, so that's all. So let's go back to the previous one. So we have a point and slope format, y minus y1 equals m, x minus x1, and we did that. And we have a line equation with 2 points. So 2 points are given, x1 and y1, x2, y2. Then we can find the slope m, and then we can get the line equation, y minus y1 equals y2 minus y1 over x2 minus x1, x times x minus x1. And slope-intercept form, this is what I mentioned before. So the slope-intercept form is the y-intercept is b, implies we have 0, b. B is a given point, and then we can use y minus b is m, x minus 0, which is just mx. When we simplify this, we get y is equal to mx plus b. And this is called as a slope because we know the slope m, and intercept because the b represents the y-intercept. So this form is a slope-intercept format. And by looking at this, we can easily tell the slope. The slope is m, and the y-intercept is b. Now we want to find the equation for the line. With the y-intercept is a 7 over 2, and the slope is a negative 5 over 2. So when you plug in, we have y equals m, which is negative 5 over 2x, plus y-intercept, which is a 7 over 2. That's it. This is the answer. Or, depending on the choice, if you don't like the fraction or the denominator, we can remove the denominator, right? We have a denominator as a 2, which is a 5/2, and then also 2, which is a 7/2. So we can multiply by 2 on both sides. Then we have a 2y is equal to negative 5x plus 7. And then we can change this into 5x. So move negative 5x to the left-hand side, which is a 5x plus 2y is equal to 7. So we can change this into the standard format. And that is a standard format. Any question? Okay. Now let's look at this. Now we're going to graph the line with the equation y equals negative 2/3 x plus 3. Now in this format, what is the slope m? Slope is
Is it negative 2/3?
negative 2/3, and y-intercept is
3.
3. You mean the 3,0 or 0,3? Or just 3?
3.
No.
0.3.
Y-intercept is a point. The point always need x coordinate and y coordinate. So y-intercept is when x is equal to 0. So 0, something.
Oh, yeah.
So for this case, this number, 3 plus 3 is a y-intercept.
Yeah.
Now what is the x-intercept? So to find the x-intercept, the x-intercept is when the y is equal to 0. So plug in y is equal to 0, which is a 0 is equal to negative 2/3 x plus 3, which is a 2/3 x is equal to 3, which is x is equal to 3 times 3/2, which is 9/2. So 9/2 is x-intercept. Now we have x-intercept and y-intercept. So we have a y-intercept 0,3, and we have x-intercept 9/2, and we connect them, and that's it. This is a graph.
On the test, are you going to give us graphs or we have to draw them?
You may have to.
So, I mean, should we get graph paper to work on
No.
it? No.
You can just draw that like
Okay.
this. You don't need to like actually like measure.
Yeah, because I'm
As
thinking.
long as you put the number here, like the 9/2 and the 3, that's fine.
Okay.
You don't need to like make a tick mark, 1, 2, 3,
Right.
etc. Yeah, I think you don't need to.
Okay.
Any other question? Now we're going to find the slope-intercept form. The slope-intercept form is like the y equals mx plus b of the equation of the line, and it said that it is parallel. It is parallel to the given equation. 2x plus 3y is equal to 6. And then it said that it passed through a point. So we know the point. A point is given as negative 4,0. x0 and y0 is given as negative 4,5. That's given. So if we know the slope m, then we can have y minus y, well, I use x. Let's use x1 and instead of 0, x1 and y, x1 and y1. So y minus y1 equals m, x minus x1. We can use this formula, like the slope and 1 point case. which is a point and slope format. So we need to figure out the slope m, right? So to figure out the slope m, we have to use the given information. This line is parallel to 2x plus 3y is equal to 3. So this is parallel to 2x plus 3y is equal to 3, is equal to 6. The parallel this line means they have, parallel means they have the same slope. That's the parallel, right?
Because two parallel lines are just side by side.
Yeah,
in the
just
same
side
direction.
by side,
Yeah.
so they have to have the same steepness, which is the same slope. Now we have to find the slope from here. So to find the slope, we have to convert this standard form into y is equal to mx plus b, because that tells us the slope m. So we solve this for y, which is a 3y equals negative 2x plus 6, and y is equal to negative 2/3 x plus 6 over 3. Now we don't care about that constant, we only care about this slope. So that means the m is negative 2/3. So m is a negative 2/3, so plug in, and y minus 5 is equal to negative 2/3 x minus, and x1 is a negative 4, so minus minus, which is a positive 4, which is negative 2/3 x, negative 8/3. Now the y is equal to negative 2/3 x, negative 8/3 plus 5, which is negative 2/3 x. And we can make a same like the common denominator, which is a 3 for this case. Then the 5 is the same as the 15 over 3. That's the 5. So which makes 7 over 3. So that's it. Y is equal to negative 2/3 x plus 7 over 3. That is the slope-intercept form of this kind of equation.
Okay, so explain that. That's a slope-intercept form of that. So what is negative 2,3x? Is that a point on the x?
Which one? Negative 2/3?
Well, the answer, when you say that is the answer, what is that saying? The slope or the intercept?
This is just line equation we want to find. The line equation we need.
But what is...
We want to find the slope-intercept form of the equation, of the line. The first thing is we have to find the line equation, right?
And that just means each point, the 2 points that you connect, that's the line equation, or no?
Yeah, that's not a line equation,
Yeah.
but we don't know the second point,
Yeah.
right? We only have a 1 point. 1 point is given,
Yeah.
and then we can get the slope. Instead of a given point, another point, we can get the slope from here. From 2x plus 3y is equal to 6. We can get the slope. Now we have a slope m, which is a negative 2/3. And then we have a one single point. When you have a slope and a point, 1 point, then we can use a formula,
Right.
which is this. A point and slope form, y minus y1 equals mx minus x1. Now the m is given as negative 2/3, and y1 is given as 5, and x1 is given as negative 4. So we plug in. Then this is a line equation. Now you can say that this is a line equation, but we also want to change this into the slope-intercept form, which is in this format, the specific format. Does it make sense for it? No.
Well, what you're saying does. My question is the final answer.
Final answer
Yeah,
is this.
and trying to understand what that actually represents. Are we talking about a negative 2/3 on the x line? That's what minus 2/3 x is?
Negative 2/3 is the slope.
Okay.
Negative 2/3. This negative 2/3 means the slope.
Okay.
The slope is negative.
Uh,
So, well, we can draw that if you like. So,
Just trying to understand what exactly those numbers and the
Okay.
answer is, you know?
so
If I can help you.
y equals negative 2/3 x plus 7/3. That this represents the slope of the line. The slope is negative, and this represents the y-intercept of the line. So when you have a y-intercept, which is this, 7/3, and then when you know the one single point, one other point, as I said, we can draw the line, right?
Right.
And from here, we can get the another line, another point, which is x-intercept. We can find the x-intercept. So how can we find the x-intercept? We let the y is equal to 0. When you solve that, the x value is 7/2. You can solve that. So we have a 7/2. This is x-intercept. And then when you draw this, when you connect this, you get this kind of a line. And in this line, the stiffness is negative because in this direction, the direction is negative. So that stiffness, negative stiffness is the negative 2/3. That is the slope of this line. That's the meaning of that stiffness, negative 2/3. Or the slope, negative 2/3. Does it make sense?
Yeah, more and more.
Now we're going to find the slope intercept form, which is again y equals mx plus b. So we are going to change the form, the final solution into y equals mx plus b. And it said it is perpendicular to this and passing through the given point. So we still use the same thing. Y minus y1 equals m x minus x1, where a point x1, y1 is given as negative 4, 5. Now we have to find the slope m. But it said to find the slope m, we have to use the information. This line is perpendicular to the given line. So perpendicular means the line intersects like this way with a 90 degree. That's the perpendicular. The property of the perpendicular line is when the slope of this one is m1, when the slope of this line is m2, then m2 is equal to negative 1/m1. That's the property. Or m1 times m2 is equal to negative 1. That's the property of the two lines, the perpendicular lines. Now we know the slope of this because we already found that. The slope of this line is negative 2/3. We computed that in the previous example, which is here. We computed that the slope is negative 2/3. So m times negative 2/3 should be negative 1. M times m2, m1 times m2 equals negative 1, which is m, our new slope m times the given equation, the slope of the given line equation, which is negative 2/3, is equal to negative 1. Now we are going to get the m to get the m, we have to divide by this quantity, negative 2/3. So negative 1 divided by negative 2/3, which is negative 1 times, we flip that, negative 3/2. And negative makes positive, so positive 3/2. So positive 3/2 is a slope. Then we have y minus y1 is 3/2 x minus x1. And this is the line equation. Now we also want to convert this line equation into this format. Y equals mx plus b. And we can do some algebra. Then what we get is y equals 3/2 x plus 11. Now you can simplify that. So this is a final answer. Y equals 3/2 x plus 11. So that says the y-intercept is 11 and the slope is a positive 3/2. So if we draw that, the line looks like this. It has a positive slope, and then this y-intercept is 11. And we have to figure out this x-intercept. Yeah, you can find the x-intercept. But anyway, that is that form. Yeah.
On the step where you said we had to do a little algebra and you ended up with the final answer, y equals.
Yes.
How did you get 11? I mean, if you add 5 to both sides, isn't that 9? Where did 11 come from?
So, okay. Yeah, let me add one more slide. So y minus 5 is equal to, is that a 3/2 x plus 4. So distribute the 3/2, and we have 3/2 x plus 3/2 times 4, which is a 3/2 x plus, we can cancel, divided by 2, which is a 6. Then add 5 on both sides,
Yeah.
and we have 11.
Okay.
Any other question? Okay. And this line is, the line equation is used in some kind of model, mathematical model. So the linear model is, well, the official name of this is the least square model. So we want to make the reduce, well, this is when you plot this point, we got actually a very nice straight line when you plot this. And we want to find a very, like the best, some sort of like the best model, best like the linear model to fit into the data point. So average annual tuition and the fees for in-state students at public 4-year college are shown in the below. So that's like the tuition. And we want to graph the data. So basically plot the data point. We have 7 data points. Just plot the 7 data point. And then let x is equal to 0 correspond to 1990, which is the beginning point, 1990. And x equals 4 correspond to 1994, which is that point is 1994 is just simply 4 instead of 1994 to reduce the kind of the algebra and so on. Then what type of equation might the model the data? So if we plot the data point, then you can easily tell that. So let's plot that. So we have a 0, that point is a 0, and this is a 4, 6, 8, and this is a 10, 12, 14. So we have a 0, well there is like a skip up 2, so 0, 4, 6, 8, 10, 12, and 14. So from the 0, we have a 2, 4, 6, 8, that's the 2 dance. Well, that's okay. So 6, 8, 10, 12, and 14. And that is X value or the year. And the Y value is $1. So we have a, well, the most basic is 2,035, and then we go up to the $4,920. So let's say that we make the tick as 1,000, and 2,000, 3,000, 4,000, and 5,000. Make a dot, draw this kind of dotted line. And then we also draw the dotted line here. You can make it better. At 4, we have a slightly above than 2,000, so around this point, almost the same as like a 2,000, right? At 6, we are very close to 3,000, so around this point. At 8, did I miss something? Oh yeah, that is a start from 0, sorry. So at 0 we have 2,000, almost 0. Sorry, yeah, I made a mistake. So at 0 we have almost 2,000. At 4 we have almost 3,000. At 6 we have slightly above than 3,000. And 8 we have half of 3,000 and 4,000. And 8, that's the 10. 10, we have almost the 4,000, close to the 4,000. And 12, we have slightly above the 4,000. And 14, we have somewhat like close to the 5,000. So when you draw that, well, let's use this one. So we may get something like this kind of the line. We can make a very like the curve thingy, but instead of the curve, usually the curve is a lot more complicated. But if we use a just straight line, then may be a good model for this data set.
But shouldn't the line have endpoints? The data has
The
a
line
certain end.
do not have any.
Even on a graph like this?
Yeah, they don't have an endpoint. The line segment has
Right.
endpoint.
But I mean, when you graph this right now, shouldn't you be using the line segment since the data is finite from 1990, 2004? It doesn't go
Well,
on.
I don't need to draw the line, this line. I do not need to draw this line because that's just graph the data, right? The graph data is just plot the data point, the dot, only the dot point. And then, what type of equation might model the data? The line equation or the linear model. So the linear model may fit the data pretty well, right? When you draw the line.
Linear model what?
The linear model, or just straight line, is a good model for this data.
So are we supposed to write that in the linear
Yes.
form?
Yeah. So we wanna write down that model, but we'll find it. So don't worry. So depending on the choice of our data point, because for the data point we need the two data points to draw the line, right? Depending on the choice of the 2 points, we may have different line equation, obviously. But more or less, they are the same. They are similar. Because the line fit the data point pretty well. So let's do some experiment. Now we want to find an equation that models the data by using the two given points, 1990 and 2002. So 1990 is this initial point, and 2002 is this point. So we want to use this end point and that point. And when you use these 2 points and draw that, we may get a one linear model for the line equation. So this 1990 corresponded to x is equal to 0, and 2002 corresponded to x is equal to 12. So we have a 0, 2035, and then 12, 4273. So we have a 2 point. The 2 points are given. When you have a 2 point, we can use the formula y minus y1, 2035, y2 minus y1, x2 minus x1, x minus x1. So this is a model, the linear model, by using these 2 points. Now when you simplify this, we have y equals 186.5x plus 2035. We have this equation. So let's go back here. Now we have a data point, and then we find a model. We don't know whether this is a good model or not, but we just computed a model, one model. So why we have to compute the model, why we have to find the model is, well, by using this model, we may predict something. We may use this model to predict the future value. So that's the reason why we make a model. When your model is really good, then your prediction will be very close to the actual value. So let's use this model to approximate the cost of tuition and the fee in 2006. Now here we don't have any data for the 2006, right? So let's use this model to predict the tuition in 2006. So 2006 corresponded to x equals 16. That's the 2006. So plug in 16, then we have y equals 186.5 times the 16 plus 2035, and this is about 5019. And this is a tuition in 2016. This is like approximation by using our model. And this is a slightly higher than 2004 tuition. The 2004 is slightly below than 5,000, and 2006 is slightly above than 5,000. Any question? All right, that's all. Okay, now let's do the systems of equation in section 8.7.
Wait, all that was just review from last time?
What did...
Everything we've done up to now was just review from?
No.
So,
There is something new here.
I'm sorry, I had 8.3 as our section before, and now we're at 8.7?
Yeah, 8.7.
Oh, we're just skipping up.
Yeah, we skip some of them. So systems of equation is, instead of just one single equation, we may have bunch of equations. That's the systems of equations. So linear or first degree equation. That's the name. It's like the 2x plus 3y is equal to 14. So the linear or the first degree means for the polynomial, the degree of the polynomial is 1. That's the linear or the first degree equation. And this is a linear equation. We have x and y, so we have two variables. We may have more than two variables, like 4x minus 2y plus 5z is equal to maybe 14. Then this is a linear. It's the same linear equation with three variables. So we have x, y, and z. We have three variables. That's the linear equation. Now the systems of equation, or the systems of especially, systems of linear equations means instead of just one equation, we may have two or three equations. So it looks like the 5x minus 3y is equal to 7, and 2x plus 4y is equal to 8. So we have two equations and then two variables. This is two equations. And two variables. Or we can have three equations. Or we can have three equations, and then we may have instead of three variables, we may have four variables. 4x plus z plus w is equal to 0. So this is the three equations. In 4 variables. Yep.
So would you call those bottom ones a second degree and a third degree set of?
The second degree is like the x squared, something like a 2x squared minus 3x plus 1 is equal to 0. That's the second degree.
So
degree 2, yes.
So the first degree just says there's no exponents.
There is no x.
Right. So all these are first degree,
Yeah.
just different variables.
Yes, right. And when you have a systems of linear equation, we typically need to solve or need to find the values. So we say that that value which makes these two equations are the true statement. That value, those x values and y value, we call that is a solution of the system. So a solution of a system is a solution that satisfies all the equations in the system. So a solution of the first equation, first system, means, well, if we have x and y such that when you plug in x and y in this equation, that makes the first equation as a true statement. And also the same x and y, if you plug it into the second equation, that also makes the equation as a true statement. That is the solution. Now, depending on the choices, we have for the linear case, we have 3 different types. So the linear equation is the same as a straight line, right? So for the straight line, the two straight lines may intersect at one point when their slopes are different, or two straight lines may be the same, or the two straight lines may never meet, which means they have the same slope, or they are parallel. So there are 3 different types of the systems. So the first case, there is only one solution. So this point, 3, 2, satisfies the first equation, the blue equation, which is a 3x minus 4y is equal to 1, and also satisfy the second equation, 2x plus 3y is equal to 12. There is only one point or one intersection mean the given point satisfying the both of them. And for this case, you cannot see the second line, which is supposed to be a red line, because they are the same equation. So they are the same equation means that we have 2 lines, but they are the same. That means they intersect infinitely many times. So there are infinitely many solutions which satisfy this. So basically, all points on the line satisfy the 2 equations. And the parallel line means they never intersect. So there is no x and y which satisfy the both of them at the same time. So there is no solution for this case. So the solution means, for the line equation, the solution means when they meet, or when they intersect, that point is a solution. That point may be just one single point, like the first one, or that point may be infinitely many points, like the second equation, or maybe there is no such point, which is like the third case. Yeah.
How is the second equation representing infinity?
Okay. So, negative 4x plus y is equal to 2. And then the second equation is 8x minus 2y equals negative 4. These two are the same. The reason is when you multiply by the negative 2 on the first equation, we get the second equation. So basically, instead of just two different equations, we only have one equation here. Now you are saying that why there are infinitely many solutions of this, right? The reason is when you draw the line, for example, we want to just find x and y, right? So if we draw the line y equals, when you move this negative 4x to the right hand side, we have y equals 4x plus 2. When you draw the line on the plane, it looks like this. This is a 2, and that is a negative 1/2. Yeah, negative 1/2. So, why there are infinitely many? This point satisfies this equation. And this point satisfies this equation. But this point also satisfies this equation. And that point satisfies this equation. So all points on the line satisfy this equation. Isn't it? That's the line. The line is there are infinitely many points. When you connect the infinitely many points, we can draw the line. That's the line. So there are infinitely many solutions. Now, the first one is called as a system. Although we don't use this definition, but anyway, the system is consistent. So when you say that the system is consistent, there is a solution, at least one solution. And then for the equation, we have two different equations, and they are not the same. So the equation is independent. Equations are independent. And for the second case, the system, we say that consistent because there is a solution. And for the equations, the second equation can be generated by the first equation. So they are dependent. The second equation depends on the first equation. So we say that the equations are dependent. And when they never meet, or when the two lines are parallel, the system is inconsistent. There is no solution, and the equations we cannot get the second equation, this equation, from the first equation. So they are independent. But don't worry about this kind of notation. I'm not going to use that. So, all right. Now we are to solve the equation. So there are many ways to solve the equation. One way is a substitution method. And after this, we'll take a break. So the substitution method is we change the first equation. From the first equation, we get a negative y equals negative 2x plus 1, which is y is equal to 2x minus 1. Now, we substitute this y equals 2x minus 1 in here, in the second equation. That's the substitution. So we get a 3x plus 2. Instead of y, we use a 2x minus 1 is equal to 4. So we have a 3x plus 4x minus 2 is equal to 4, which is a 7x minus 2 is equal to 4, which is a 7x is equal to 6. So we get an x equals 6 over 7. Now we have x value. Now we are going to find the y value. To find the y value, we can use either the first or the second, but when you plug in the x value in here, we can get the y value. The y value is a 2 times x minus 1, which is a 12 over 7 minus 1, which is a 12 over 7 minus 7 over 7, which is a 5 over 7. So the solution is 6 over 7, 5 over 7. And that is the solution of this system. Alright, let's take a break.
Section 216, section 2.
The next one is the elimination method. So the previous one is the substitution method. The way is, the first thing is solve for y, or it doesn't need to be y, but like to solve for either x or y. So for this case, we use a y equals 2x